Hi, this is Lina.
Hi, this is Joy Lee. And first, I will introduce you about two external data source. The first one is dishes. We get the dishes from this API, and here is the link for that API. It contains dishes in different restaurants throughout the whole country. So we have already contained every state in US. We use this data to explore difference about dish prices and implement make order functionality in our project. The second external data source is reviews, and we download this data set from Yelp. Here is the link. So it contains many review records towards specific restaurant and customer. This data can be used to explore how people think of one specific restaurant and people's habits of rating and commenting a restaurant. Lena would introduce about ETL workflows.
So here is our data source. It's from the Yelp dataset, and it's in the JSON format. So first we read the data from JSON format, and store it into the database reviews table. Um, now we read this. Now we read the data from this table, and put it into the aggregate transformers. Here we group the data by the user ID, and calculate the average rating of this user, and then we generate a chart to show the average rating of each user.
So here, use this ETL workflow, we can get a chart, and I have attached this chart 3 here. So this is the chart 3. Our hypothesis for chart for this is users would rate restaurant from 0 to 5. Ratings would be evenly distributed between 0 and 5. Thus, average rating of most users should be around 2.5. But the result is not like our hypothesis. Most average ratings for all users are above 2.5, and they are mainly distributed between 3 and 5. So for this chart, uh, the x-axis represents different users, and the y-axis is their average rating. So another chart I would like to introduce is chart 4. So about this chart 4, our hypothesis is that restaurants' average price would be between 0 to 50, and every state has a few expensive restaurants and some cheap restaurants. So the x-axis from left to right, representing different restaurants, and the y-axis is their average price. So we can see from the chart, the result validates our hypothesis. Restaurants' average price is between 0 to 50. Most restaurants, the average prices sit here, and every state has a few expensive restaurants. Those isolated points representing expensive restaurants. These two charts are both very important. Uh, for this one, it's very important because knowing this would remind users that most users prefer to give high ratings rather than give ratings from 0 to 5. So restaurants whose ratings are around 2.5 is actually not at average level. When choosing a restaurant, it is better to choose restaurants with ratings 3 or higher. And if given new information, users should adjust their rules about choosing restaurant to new trends. And for this chart, it is very important because knowing this would help users to choose restaurants. They would choose to go to an expensive restaurant to celebrate something or go to a cheap restaurant for their daily meals. Given new information, users can also adjust their rules when choosing restaurants to new trends. So that is the introduction about our data source, our ETL workflows, and our two charts.